We are moving to the next section, the inverse of a function. It is not a tough section as you think. We have been dealing with inverses throughout our life. Do you know who was the first teacher who introduced to you the concept of inverse? It was not me or your high school teacher, but it was your nursery teacher.
1, 2, 3, 4, 5. 1, 2, 4, 5, 6, 7, 8, 9, 10. Then I let him go again.
Thus, inverse is a very simple concept that even a nursery student can feel. A child caught a fish. After some time, she felt to release it. If f is the action, f is the function of catching the fish, then the opposite action, the reverse action, f inverse is that releasing the fish. Thus, the fish in the pond became the fish in the hand. After applying f inverse, the fish in the hand became the fish in the pond. Thus, if we apply f after f inverse, the input, that is fish in the pond, comes to be the fish in the pond. This is same as x becomes x itself. This is same as applying the identity function in mathematics. Thus, if f and f inverse. If f is catching the fish, what is f inverse? It is a reverse activity, that is releasing the fish. And if f is doubling something, what is the reverse activity? Doubling. The reverse activity of doubling is nothing but having it, making half. F inverse is having. That is, in doubling, if x becomes 2x, then after having it 2x by 2, after having it 2x again become x. Thus in doubling, if applying f in doubling, x became 2x, and after having 2x by 2. After having f inverse, after applying f inverse, 2x became x itself, as the fish in the pond at last became the fish in the pond itself. If you are clear with this idea, you have nothing more to study about the inverse. But in mathematics, we have to apply some terms like, we have to go through some terms like domain, range, f inverse, etc. only to avoid the loopholes. Let us go through some problems. Now let us come to a theoretical problem. Let A equal to set 1, 2, 3. A contains 3 elements 1, 2 and 3. And let f is defined from set A to set A itself. We have given a function f equal to set 1, 3, 3, 2 and 2, 1. We have to find what is the f inverse. F equal to set 1, 3, 3, 2 and 2, 1. What is f inverse? The question is that what is f inverse? What is f inverse? We know that F inverse is a reverse activity. Then what is F inverse? 1 is related to 3. Therefore, in F inverse, 3 should be related to 1. And if 3 is related to 2, 2 should be related to 3. And if 2 is related to 1, then 1 should be related to 2. Therefore, F inverse is the reverse function given by F inverse equal to set 3 1, set 3 1, set 3 2, set 2 3, and set reverse of 2 1, that is ordered by a 1 2. Thus, F inverse equal to set 3 1, 2 3, and 1 2. Let us draw an arrow diagram representing this. Given that F is a function defined from the set A to A contains 3 elements 1, 2, and 3. Again, A contains the 3 elements 1, 2, and 3. And F is defined from A to A. F is a function defined from A to A. Here, 1 is related to 3 in F, 1 is related to 3, and 3 is related to 2. 3 is related to 2, and 2 is related to 1. 2 is related to 1. Therefore, what about F inverse? F inverse is the reverse function from A to A itself. Therefore, let us draw F inverse. F inverse is defined from the second set to the first set. A to A, and 1, 2, 3, F inverse 1, 2, 3, and here 1 is related to 3. Therefore, in F inverse is from second set to the first set. Therefore, in F inverse, 3 should be related to 1. 3 should be related to 1, and 2 is related to 1. Therefore, 1 should be related to 2, and 3 is related to 2. Therefore, 2 should be related to 3. Therefore, F inverse is the ordered pair 1, 2, 2, 3, and 3, 1. Thus, we have found F inverse. But we have learned in the last section that if F inverse to exist, F inverse need not exist in every cases. If F inverse exists, the function should be both 1, 1 and 1, 2. That is, it should be a bijective function. If it is not a bijective function, we cannot define the function from the second set to the first set. Let us go to such a problem. Now consider this problem. A equal to set 1, 2, 3. A equal to set 1, 2, 3. The same set we have taken in the previous problem. And F is defined from set 1, 2, 3 to the same set 1, 2, 3, A to A. And if the function F was such that F equal to set 1, 2, 2, 3 and 3, 2. What can you say about F inverse? What's your opinion about F inverse? See, let us draw its arrow diagram. Function defined from the set A to the set A F, and A contains the elements 1, 2 and 3. Here again A contains the elements 1, 2 and 3. The function is defined such that 1 is related to 2, 1, 2. 1 is related to 2. Then 2 is related to 3, 2, 3. And 3 is related to 2. 3 is related to 2. Do you feel that there is some complication in this problem? Can we find F inverse? If we find F inverse, if we define F inverse, how will it be? It should be, if we try to define F inverse should be from A to A itself, but in the reverse way. A to A. A to A. 1, 2, 3. And here also 1, 2, 3. Since 1 is related to 2 in F inverse, if F inverse is possible, 2 should be related to 1. And since 2 is related to 3 in F inverse, 3 should be related to 2 if possible. 3 should be related to 2. And 2 should be related to 3. The problem is that whether F inverse exists or not. You may have got the idea. Here F inverse does not exist. Why? Because if we try to define a function from the second set to the first set, it is not possible. It is only a relation. It is not a function. Why it is not a function? Here 1 has no image, while the element 2 has 2 images. Therefore, the reverse function, the inverse function, does not exist. Theoretically, we have said earlier that a function, for F inverse to exist, the function should be both 1, 1 and onto, or it should be a bijection. Here, the given function is not a bijective function. It is not 1, 1 because 2 has 2 pre-images 1 and 3, and the element 1 in the codomain has no pre-image in the first set. Therefore, it is not 1, 1 and onto. We can write F is not 1, 1, or neither 1, 1 and onto. It is not 1, 1 or onto. Therefore, here F inverse does not exist. Thus, for F inverse to exist, the function should be both 1, 1 and onto. Here, F inverse does not exist. Thus, we have already mentioned that if F is doubling, F is the action of doubling, then its inverse activity is halving, making half, halving. It means that if f of x equal to 2x, the inverse activity is f inverse of x equal to halving. F inverse of x is x by 2. We can represent it simply, but in a question paper or in a mathematics textbook, the same process, the same question appears as consider f defined from real numbers to real numbers given by f of x equal to 2x. Show that f is invertible. Invertible means inverse exists. Also find f inverse. Let us do the theorem. Let us solve it theoretically. First, we have to show that the function is 1, 1. 1, 1. How to show it is 1, 1? You remember we have already done it in the previous class. Let f of x1 equal to f of x2. Let f of x1 equal to f of x2. Let f of x1 equal to f of x2. We have f of x equal to 2x. Therefore, f of x1 is 2x1. 2x1 equal to 2x2. Therefore, 2 is cancelled. We have x1 equal to x2. The function is 1, 1. 1, 1. And how to show that it is onto? Let there is an element y in the second set such that y equal to 2x. Let y equal to 2x. Then we have x equal to y by 2. Then we have x equal to y by 2 belongs to R. That is, if there is an x in the first set, its image is 2x. And if there is a y in the second set, its pre-image. Y in the second set, the image of y under f inverse is y by 2. is y by 2. Thus, x equal to y by 2. There is an x. If there is a y in the second set, there exists an x in the second set such that x equal to the half of y by 2. It is also a real number. Y by 2 belongs to the first set of real numbers. It is a set of real numbers and a set of real numbers defined from R to R. F is defined from R to R. Thus the function is on 2. Thus the function is both 1, 1 and on 2. If the function is 1, 1 and on 2, we know that it is called a bijective function. If it is a bijective function, if it is both 1, 1 and on 2, we can find the reverse relation called the inverse. Thus, since it is bijective, it is invertible. Invertible means what x is? Inverse x is. The function is f is. The function is invertible. F is invertible. And what is the inverse of the element y? It is y by 2. We can write f inverse of y equal to f inverse of y equal to y by 2. Or we can write if x is the element, f inverse of x. If there is x in the second set, its image is x by 2 under f inverse. F inverse of x equal to x by 2. It is the inverse of f. Find f inverse. F inverse of x equal to x by 2. We have already written that the inverse of x is. We have already written that the inverse of x is x by 2 itself. And it was a simple activity, but we have to write so many steps to prove that the function is invertible. Theoretically, to prove that the function is invertible, we have to write so many steps. And if the question was f of x equal to 2x instead of 2x, if the question was f of x equal to 4x plus 3, 4x plus 3, 4x plus 3. Can you guess the answer? If the question is f of x equal to 4x plus 3, can you guess the answer? We have f of x equal to, I am not going to do the problem, but we can get the answer simply. We have to prove that the function is 1, 1, 1, 2, etc. But we are trying to guess the answer. F of x equal to 4x plus 3. What is f inverse of x? What is f inverse of x? See, the activity is that first x is multiplied with 4 and then 3 is added. And to get x back, x reversely, first we have to reduce 3. We have to subtract 3. First we have to subtract 3. Then 4x plus 3 becomes 4x. And to make it x, we have to then divide it by 4. See, we are trying to guess the answer. F of x, the action of x, the function of x is that 4x plus 3. X became 4x plus 3. Then what is the reverse activity? First 3 is added. Then 3 is subtracted. 4x plus 3 minus 3. It becomes 4x. And again to get x, we have to divide it by 4. Thus, f inverse x, the action under f inverse is that, f inverse x is that at first we subtracted 3 from the function and then we have to divide it by 4. Then f inverse of x equal to x minus 3 divided by 4. And we have to do it in the formal way as we have done in the previous problem. How? First we have to show that it is 1, 1 and on 2. And then we write let y equal to 4x plus 3. If it is invertible, let y equal to 4x plus 3. Then y minus 3 equal to 4x, or x equal to y minus 3 divided by 4. X equal to y minus 3 divided by 4. It is the inverse of y. F inverse y equal to y minus 3 divided by 4, or f inverse x equal to x minus 3 divided by 4 is the inverse of f of x equal to 4x plus 3. I think you remember the composition of functions we discussed in the last section. The composition of functions f and g, g of f or g composite f, g of f or g composite f of x equal to g of f of x, g of f of x. Now, what happens if we take g as f inverse? For example, let f of x equal to 2x that we discussed in the previous example, and g of x is same as f inverse of x equal to, we have proved that f inverse of x equal to x by 2. Doubling having f inverse of x equal to x by 2. And what happens if we find f inverse of f of x equal to f inverse of f of x is 2x, f inverse of 2x equals f inverse of x is x by 2. Then what is f inverse of 2x? That is equal to 2x divided by 2 equal to x itself. Thus, f inverse composite f of x equal to x. And similarly, f of f inverse of x equal to f of f inverse of x, f of f inverse of x. And what is f inverse of x? F of x by 2, f of x by 2. That equals f of x is 2x. And what is f of x by 2? And we have f of x equal to 2x, doubling. Therefore, f of x by 2 equal to, it is 2 into x by 2. That equal to x. Thus, we have the surface that f inverse of f of x equal to x. That is the identity function. And f of f inverse of x equal to x. Thus, we have the idea that if the two functions are inverses of each other, then their composition will be x itself, f inverse of f of x equal to x and f of f inverse of x equal to x. We get the identity function. Thus, we can verify that whether the given function, the given function and its inverse, whether the second function is the inverse of the first function or not. See, here f is catching the fish and f inverse is releasing the fish. Thus, another way of checking whether the given two functions are inverses of each other, we have just to find f inverse of f of x and f of f inverse of x. We have f inverse of f of x equal to x. That is, if two functions are inverses of each other, then their composition gives the input itself, the initial value itself. I am going to explain it using the nursery rhyme. If you are interested, just a motivation. We have f inverse, we have f is the function of catching the fish in the water and f inverse is releasing the fish. Now, f inverse of f of fish in the water, that is, f inverse is releasing the fish, that is releasing the caught fish. Releasing the caught fish is fish in the water itself. We got the initial value itself. I think you are motivated. Thank you. So it is just for a motivation. We have f inverse of f of x equal to x and f of f inverse of x equal to x. Now look at this worked out example. We have f of x equal to 4x plus 3 divided by 6x minus 4. where x not equal to 2 by 3. We have to find f of f of x. We have f of x equal to f of x. That is f of x. That equal to f of x is 4x plus 3 divided by 6x minus 4. Therefore, the answer is 4 into this value in place of x. 4 into 4x plus 3 divided by 6x minus 4 plus 3 divided by 6 into the value minus 4. It can be simplified to 34x divided by 34 equal to x. Thus we have f of x equal to x, which means that we have only f inverse of f of x equal to x and f of f inverse of x equal to x. And it means that here we have f of x equal to x. It means that f is nothing but f inverse itself. Here in this problem, the function is same as its inverse. Thus f inverse equal to f. We were just discussing what the inverse of a function is and the methods to find the inverse. And I think you are okay with the section. Thank you.